Okay. Hi guys. Good evening. Welcome for week 11 Hacker School. So this is going to be a very simple workshop on an introduction to Python. I would also like to apologize in advance. This workshop is quite last minute, so the slides are maybe not the best you've seen. Very like old slides that have just been repurposed for this. So I apologize for that, but I will try to do my best with like lots of demos and whatnot. There's a QR code over here, or you can look at the TVs and you can scan the QR code, follow along with the slides. Yeah, without further ado, let's get started. This is the content that I'll be going through for today. So we'll start with a simple introduction, and then we'll look at our first program using input, output, and some variables. We'll then look at the different data types available, some operations, conditionals and condition statements, and loops. Um, at this point, after this part one, we'll have a little break. You guys can have some Subway cookies. And then we'll move on to part two, which will be a little bit heavier compared to part one. And I'll keep the time in mind as well as trying to focus on explaining things instead of just finishing stuff. So I may not get to the end of like modules and dictionaries, but I'll do my best anyways. So functions, iterables, strings and lists, dictionaries, and modules. And that will be the end of the workshop unless we somehow end way ahead of time, in which case I'll improvise. Um, yeah, so my name is Prakame Singh. I'm a CS student here at NUS year three. I'm actually part of the NUS Hackers core team. Currently this time I'm working on Friday Hacks if you guys are interested. I've previously worked on Project Intern as well. When it comes to Python, my experience has mostly been in web development, some data analytics and data presentation, scripting, as well as a little bit of AI agent architecture. And previously, I've given hacker schools on Flask and SQLite last semester. This is the setup I've been using. This was in the pubs message as well. I'm using Visual Studio Code as my IDE. I have these extensions installed, the Python extension package from Microsoft. Again, I'll show all of this when I get into the demos. I'm using macOS Python version 3.14. I just reinstalled today because of some issues. And yeah, we'll get started with our first program. But for this, I'm just going to show like what you should expect to see when you have Python properly installed. You guys can open up the terminal on your laptops. So if it's on macOS, you can just type in terminal and look for the app. On Windows, you can probably look for the command prompt. And once you have it open, you're going to type in very simple this command. So you're typing in py, which is short for Python. You're adding in a space and then two minus signs and the version. So this will show you the version of Python that has been installed on your system. And you should see Python 3.14.0 or some other version. Any issues? If that doesn't work, you can also just type in Python. Okay, no, Python 3 fully. You guys okay over here? Okay. So if py doesn't work, just try Python 3. Yeah, is the font size too small on the TVs? I can increase the font size. Is it okay? Okay, great. So good, looks like we all have Python installed. That's very good. I'm assuming everyone is using Visual Studio Code for the IDE, or do you have your own special choices? The IDE that I mentioned in the Telegram chat, in the poster message, basically, I assume everyone is using that? If yes, you're just going to want to open it up. So Visual Studio Code. You can open up a folder in Visual Studio Code as well, just to put all your Python files. All okay? Everyone's open Visual Studio Code as well? You guys okay on this side? You guys? There? Visual Studio Code? All good? Okay, great. Yeah, okay, so if you have Visual Studio Code open, you guys can go ahead and open up a folder. I'll show you what extensions, sorry?
You need to guide through that.
Huh?
You need to guide through how to open up a folder and stuff.
Yeah, so to open up a folder, you can just go to File and then Open Folder. I don't know if it's a little too small, I can't really zoom into that, but it might be on your screen. So File and Open Folder, or you can type Control O or Command O as a shortcut, just to open up a folder. And then once you've opened up a folder, we can start actually programming. Okay. The extensions that I mentioned, if you do want to install them, I do suggest that you install them. It takes like 10 seconds. So you go into the side panel. There's this icon with like 4 squares on the side here. Click on that. And then into the search bar on top, just type in Python. And look for this from Microsoft. Make sure it's from Microsoft. There are scammers. And then just click install. I have it installed so you don't see the button, but yeah. You guys okay? You guys okay? Okay, great. So now we are fully set up. We can start programming in Python. I hope that was a fairly straightforward process. So, okay, now let's get to our first ever program, input, output, and variables. Input is just anything that a programmer or a user gives into the program. Output is anything that the program gives back to the user. So we'll start with a simple output. You're going to just type out this one line, print hello world, and I'm going to show you how. So again, in your VS Code, you're going to click on, there's a few ways to do this. You can click on this new file icon up top, or you can type Control N, that opens up a new file. You can call that file anything you want, but do note that the file extension needs to be .py. That denotes that the file is a Python file, and it also activates all the extensions, the Python extensions for that file. So you're going to create that file, and then you see this. I have Copilot, so that's why you see generate code, but I don't know if you'll see it. Yeah, I mean, again, if you guys need help, just let me know. Everything okay on this side? This side? Okay. One second. Yeah. These guys are okay. The other one's helping the ones at the back. Sorry? The other one is helping them. These guys are okay. So once you've created your new file, the Python file, name it whatever you want, but make sure the extension or the thing at the end is .py. And then you can type in this simple line. You're going to type in print, You're going to then open up brackets, and then inside the brackets, inside quotation marks, you're going to type in hello world. You can type in hello anything, but it's I guess it's tradition to start with hello world, so we'll stick with that for now. Yes, you're here for the workshop?
Yeah.
Okay. Have you installed Python? No worries. Can you? It's very straightforward. You click a button and you're done. Yeah, sit anywhere, sit anywhere. Yeah, sorry.
Can you show the QR code? I'll take a picture of it real quick.
The QR code will be here. Oh shit. Yeah. Okay, so this is a very simple, straightforward one-line program. Nothing much is happening. You have this function, and we're going to talk about functions later, called print. Its entire job is to give output to some user. In this case, we are the user and the programmer at the same time. Inside the brackets are the arguments to print. So basically, what do I want to show the user? I just want to show the user hello world. And so I put that inside of brackets. The reason why I'm using quotation marks is because it's a string, and I want to make it clear that I'm kind of showing a sentence to the user. So very straightforward program. And then once you have Python running, once you have everything set up, you click this kind of play button looking thing at the top corner. You may get some kind of a message. If you do get like a message that doesn't say hello world, please tell us. If you click it, you'll get a window opening up and you'll see hello world. You will get some other message sometimes if it's like your first time, in which case just let us know. Okay, all okay, so I'll continue. So congratulations, you have written your first ever Python program, a very simple, straightforward one. Yes, you can give yourselves a round of applause if you want to. Again, very simple program, right? We've just given output to the user and we've told the user, hello world. But okay, I've said hello world. Let's try something a bit more complicated. Let's say hello to you, the person. So you're going to change world to whatever your name is. So just change it to whatever your name is. And then once again, just as before, you're going to run the file. And now this time we'll say hello to your name. But the thing is, what if I'm coming to your computer and using it? Then it's saying hello to you, but not to me. I want it to say hello to me. But for that, the program needs a way to know what my name is, right? And so the program can actually ask the user for input. And the program can, yeah, you literally just, you can ask the user for input. So it can ask me for my name, and then I can enter it. And then it can save my name in a variable. So variables in computer science or in programming work very similar to variables in math. They're just like, you give them a name and then you set them equal to something, and then they store that value inside of them for the rest of the program. So in this case, I'm combining two things in one. I'm combining input and variables. So first thing you'll notice is the input function. This essentially takes input from the user. I'm asking a question, which means that when I'm taking input from the user, it will ask like this question to the user as a prompt, basically. Once the user types in the thing and then hits enter, the input function will have the name or whatever the user typed in. It will then take that and store this inside this variable that I've called name. You can call the variable kind of whatever you want. I'm just calling it name to make it very clear that it's my name. So you're going to go back to your program and you're going to do this. You're going to type in basically what I told you before. So what is your name? So you're going to type in this line, the name is equal to input, blah, blah, blah. So again, same thing is happening as before. I'm asking for the user's name and I'm taking it in as input and then storing it in a variable. And then you're going to plug it into your output. So in your print function, you're going to print hello, then a comma, and then you're going to put just the name of the variable, which is name, like this. So once again, once you're done typing this out, you can run this. Run this. There. You see that the program asks you, what's your name? And just pauses there, and it's waiting for you to give your name to the program. So you're going to type in your name. My name is Prakamya. And then once you're done typing your name, you just hit enter. Then when you hit enter, it'll say hello to you. And you can try different names each time. I'm trying in a different name. I'm trying Ajay. It's saying hello. I'm going to try Jaya. It's saying hello to Jaya as well. Yeah, you can type in whatever name you want. I can type in I can spam my keyboard. It's going to say hello to whatever I just typed in. So that's how you can take input and store it into a variable. So just like the name suggests, a variable can take on any value. All right, everyone good so far? Input, output variables, your first program in Python. Very nice, very simple. The next thing we're going to do is data types. This is a bit theoretical. We are not going to do much demo here just yet. But essentially, whenever you have data or values in your program, each value takes on a different type. And obviously, these are called just data types. Python has a few different data types that you can make use of. The first type of data is just numbers. So I'm sure we all know what numbers are. Any whole number, any integer, so 0, any negative number, any positive number. Then you have decimal numbers as well. So I can just make a fraction or a decimal number that counts as a number. Python specifically supports complex numbers. So if you guys remember like imaginary numbers from school, Python supports that. And Python also supports scientific notation. So for complex numbers, you will use the letter J to indicate complex number. So in this case, 3 plus 4j just means 3 plus 4 times the square root of minus 1, if you guys remember the complex notation. And scientific notation, you're going to type it down like this. You're going to put a number, then you're going to put E, and then you're going to put another number. So in this case, if I have 4.5 E4, this is evaluated as 4.5 times 10 to the power of 4. So the number before the E times 10 to the power of the number after E. That's numbers, very straightforward. Then you have Boolean values. So Boolean values, they're named after a scientist called George Boole. And they can only take on two values, which is either true or false. And these values, true or false, are the opposite of each other, which is going to be very useful later on for comparison. And we're also going, we're going to see how Boolean values are useful in comparisons. And yeah, I mean, it's very straightforward. Boolean value can either be true or false. You kind of don't have any other option. Then you have strings. We just saw strings. So any length of any type of characters, you can put numbers or alphabets or punctuation marks, spaces, anything you like. You can put in characters from like different languages. You can put in emojis, doesn't matter. As long as they are placed in quotation marks. So either single quotation marks or double quotation marks, both are fine. I stick to double, but single is quite popular. It's up to you. So yeah, as we saw, hello world in string, hello world in quotation marks was a string that we printed out. The input function always takes in the user input as a string as well, which will be important later on. Everyone fine with data types? This is just theory for now. Okay. Then you have something called typecasting. So sometimes you have a variable or a value that's in one data type, but you want to change it to another data type, right? So let's say I mess up a little bit and I give you the value 19, x is equal to 19, but it's in a string. Now, can I do addition with a string? Can I do addition with a sentence? Can I do multiplication with a sentence? Not really. I would prefer if that 19 was a number to me, right? Or an integer in my case, in this case. So what you can do is you can do something called typecasting, which allows you to change the data type. So let's say if I had x is equal to 19, I can use the int function to typecast that string into an integer. And at the end of it, y will be 19, but it'll be the number 19 instead of a string 19. And then if you want to check what kind of a data type you have with you right now, you can use the type function. So inside the type function, you open parentheses or open brackets, and then you pass in the variable or the value that you want to check. So this we can demo. Within your same hello.py, or you can create a new file and continue if you want, just type out exactly what I typed out before. So x is equal to 19, then convert it into an integer. So just, yeah, x is equal to string 19, convert it to an integer and set that to y. And then what you're going to do is you're going to print the types of each of these. Copilot. You're going to print the type of x and the type of y. And then you're going to run the program. Excuse me. Going to run the program. So you see down here two things. First, it says class stir and then class int on the line below that. So stir is just short for string, int is just short for integer, and class is just saying that this is of this data type. So what's happened is that our x was initially a string, then we typecasted it to an integer and set that to y, and then our y is now an integer. Okay, is everyone up to speed? Everyone is fine with typecasting? Great. As I mentioned, you can do typecasting between any number of types as long as the conversion is valid. So we saw converting a string to an integer. You can convert a string to a float value as well. So float is just, it's essentially a decimal. You would have to go into like the, okay, sure. You would have to go into like the implementation of decimals and whatnot to see why it's called a float. But this will convert something into a decimal. Then you have str, str, that converts anything into a string. Then you have bool, which converts something into a true or true or false, as in a Boolean value. And later on, we'll see that there's 4 more things called tuple, list, set, and dict to convert to different data types that we'll come to in the second half of the workshop. But yeah, you guys can try it out if you want. I'll give a couple minutes. You guys can start off with maybe set x is equal to 1.3 as a string, try to convert it to a float, and also try to convert it to an int to see what happens, just to see that there is an error. Then you can try and convert maybe the number 45 into a string. You can convert something back into a Boolean value. Yeah, you can just play around for a couple minutes while we set up. Okay, so that's typecasting and types. Next we move on to, sorry?
You should explain what int, bool, and float means.
What do you mean?
People are not familiar with it.
I literally just talked about it, no? Okay, my bad. So I'll go over it again. Int stands for integer. As you know from just like basic math, or I guess high school math, I don't know when you learned about integers, but integers in math are just any whole numbers, either positive or negative, right? So -1 is an integer, 10 is an integer, 0 is an integer. So int basically converts a value to an integer. The other functions, you have float. Float converts a value to any decimal number. Again, you guys know what decimals are, so 1.3 or negative 10.7 or something like that. any number with a decimal point and some numbers after it is counted as a float number or a floating value. So the float function just converts anything into a float or tries to convert anything into a float. Then you have stir or str that converts it into a string. And then last is bool. So bool converts any value into a Boolean value, as in a true or false. Does that clear it up? I'm sorry if I didn't make it clear before. Is that okay? The explanation is fine? Okay, sorry about that. We'll move on now to operators and operations. So there are three main types of operations that I'll be talking about, at least for this workshop. There's a few more, but I won't cover those. You have arithmetic operations, comparison operations, and logical operations. Keep in mind for like the math stuff, Python follows BODMAS rule. So I hope you guys know, right, the order of operations like brackets, off, division, blah, blah, blah. Python follows that, and as do most computers, so you don't have to worry too much. And yeah, we'll get started. You have the arithmetic operators. So the four basic arithmetic operations that we know are addition, subtraction, multiplication, and division, right? We've been doing that since like second or third grade. Addition uses the plus sign or the plus character, and it works as follows. Like if I have two numbers, I can add them up. I can add up any number of numbers if I want to. Then I have subtraction using the minus sign. So again, subtraction works as expected. You can just subtract two numbers. I then have multiplication. Multiplication uses the asterisk or asterisk. Some people call it, I don't know how it's pronounced, or just the star. I think it's Control-8 or Command-8 on your keyboard. Again, that just multiplies two numbers. I don't need to go over this. And division uses a slash. Note that it's a backslash, not a forward slash. Wait, there's a backslash, right? Okay. It's a backslash, not a forward slash. So the one with your question mark key. There's more arithmetic operations. So exponents, as in power, you use a double asterisk with no spaces. So in this case, 4 double asterisk 3 just means 4 to the power of 3. And that's obviously 64. Then you have flow division. So flow division just returns the whole number of division. So for example, and for that I use a double backslash. So for example, if I have 10 flow divided by 3, if you do 10 divided by 3, normally you'll get 3.33333 and so on, right? But flow division ignores the decimal part. It only keeps the float value or the whole number part of the answer. So in this case, 10 divided by 3, 10 flow divided by 3 is just 3, and I ignored the decimal part. Is that okay? Then I have the modulo or the modulus operator, and this does the opposite. It gives you the remainder of division. So in this case, 10 divided by 3 has a remainder 1. So 10 modulo 3 will give 1. And the last one is string or list concatenation. I'll come back to lists in the second half, but strings. Let's say I have a string called hello and another string called world. I can use the plus sign, which normally does addition, to combine the two strings into one and just like join them together. So I think Jay showed you guys at the back there earlier, but this is what that looks like. So if I have hello and world and I add them up or add them, I just get hello world without any like things in the middle. Is that okay? And as for lists, we'll cover lists in the second half. I should remove this one, sorry. Okay, assignment operators. So we've already seen the equal to sign, right? We've set like name equal to input, blah, blah, blah. And what that does is it just creates a variable called name and then assigns the right-hand side value to my variable called name. So if I have a is equal to 45, it takes the value 45 and then assigns it to a variable called a. And then anytime I use a in my code, the program knows that, okay, it's this a which has the value 45. And that value gets sort of plugged in and used every time. Then I have operation assignment. This is kind of a shortcut that's provided in many languages. So the short form is X. Then I put the operation equal to sign and then Y. So what this does is, it's the same as doing X equal to X operate on Y. These are some examples. So if I have X plus equal to 10, this is the same as saying x is equal to x plus 10. So what that does is, we'll look at it actually. So again, you guys can continue with the same code or create a new file and do this. I'm just going to continue in the same file. I have a is equal to 10, right? And I'm going to print out a. And I'm going to type this. So I'm going to just create a is equal to 10. Then I'll print out a just to see what the value is. Then I'm going to do a plus equal to 10. And then I'm going to print out a again. Yes, I will. You'll notice that these lines are kind of grayed out. So what I've done is I've commented out these lines. So whenever you add a hash key or a hash character in front of any line in Python, Python ignores that line. Then you can type in whatever you want, and that line won't actually get executed. So that's called a comment. I'm commenting this because I just don't want this to run every time. I don't want it to ask my name every time. So now if I run this code, oh my God, what's wrong with you? Huh, what's this? Okay, ignore this. You'll notice that first it prints out 10, right? Because we initialized a to 10. And then after that, a plus equal to 10 basically increases the value of a by 10. So a is now 20. Yeah. So have you guys tried it out? Is it working? So you'll notice that the plus equal to basically just increments a by 10, right? And I can combine this with other operations and do the same thing. So let's say I have a b is equal to 5. I will print out b just to see the value before. And then I'm going to multiply it by 3. So instead of plus, I'm now using asterisk as in multiplication. So b star equals to 3. And what that does is it basically multiplies b by 3. And now if I run the code, b was initially 5, then I multiplied it by 3, so it's now 15. You guys can now see, right? So operation assignment is a pretty good shortcut to use, especially when you don't want to write out two verbose code. And many programming languages support this. Python is nothing special in this regard. And yeah, you can even do something a bit more complicated with operation assignment. So you can do something like x star equals, and then I can put a more complex expression. So it'll still evaluate to x is equal to x times whatever that expression is. Okay, the next on the list is comparison operators. So as you guys can probably guess, these operators allow you to essentially compare two values. You have your greater than or lesser than operators. So I'm sure you guys know what greater than, lesser than mean. You use the angle brackets or the arrow brackets on your keyboard to represent greater than or lesser than. You can also use greater than or lesser than, greater than equal to and lesser than equal to. To do that, you essentially just add an equal sign after the angle bracket. So for example, 10 greater than 5 is obviously true. Oh, and comparison operators always return a Boolean value, as in a true or false, which becomes useful later on. So 10 greater than 5 is obviously correct because 10 is bigger than 5. 6 less than 3 will return false because obviously 6 is not less than 3. I can use greater than equal to or less than equal to. So 5 less than equal to 10 is true. 5 greater than equal to 5 is also true because, I mean, okay, this is math. Why am I explaining so much? Then you have the equal to operator. So you guys normally use the equal to sign to show assignment in Python. So you use double equals, as in you put two equal signs back to back to check if two values are exactly equal to each other. So for example, 4, then I put double equals and 4. 4 is equal to 4, so obviously that returns true. This operator can also be used between strings, and comparison in strings is case sensitive. So for example, I have hello, and I'm comparing these two. you'll notice that in one of them, the h is capitalized, and in the other one, the h is small. So this is false. So you guys can try that yourself. Now I'm going to create a new file, or you guys can stick to the same file. It's up to you. So anytime you want to see input, by the way, always use the print function. So I'm going to do print. Okay, so what I've typed out is I've just typed out two print statements. I'll be doing comparison. Inside the print statement, inside the brackets of the print statement, I am comparing hello and hello. The first time I'm comparing them, both are the exact same, so it should return true. And the second time I'm comparing them, the one of the hellos has the H capital, but the other one does not, which means it should return false. And once again, as before, if I run the program, I should get false, true and false. Here we go. So the first one is true because hello and hello are the exact same. But the second one is false because, again, capital letters and small letters are considered different. So you get true the first time and false the second time. If you want to check if two values are not equal to each other, you add the exclamation point to an equal to sign, and you get this exclamation equals operator called the not equals operator. And this does the exact opposite of the equals sign. It kind of just checks if both of them are not equal. If the two values are not equal, it returns true. But if they are equal, it returns false. So in our examples, you can see 4 and 9 are not equal. So it'll return true because the operator wants them to be not equal. And then hello and hello, the exact same strings with the exact same capitalization, are equal to each other, which is not what you want with this operator, so it returns false. You then have, actually, before we move on to this one, we can do a quick few demos of all the operators. You guys can also think of examples with the operators, but either in the same file as before or in a new file, given all the operators that we've done before, and you guys can obviously refer to the slides, just print out random examples of using those operators just to practice using them. So I'll work with you guys here. I'm going to do some addition, then maybe some subtraction, multiplication sounds nice, division. Note that division Python gives you the exact answer. So this, then I can do floor division, then exponents and modulo. Okay, stop that. What else is left? That's all the arithmetic, right? Oh wait, concatenation. Then I'm going to concatenate two strings. Okay, so that's all like the arithmetic operators. Then we have the comparison operators. So let's do some comparisons. I'm going to check if 4.5 is greater than 3. I'm going to check if 6 is less than 2. I'm going to check if 5 is equal to 5. And I'm going to check if it's not equal to 2. Note that you cannot check greater than and less than for strings. That will cause a problem. Going to check. Okay, so I have this set of prints ready now. So I'm just using one of every operation. I'm using addition, subtraction, multiplication, division, then floor division, exponents, modulo, string concatenation, and then I'm using the comparison operator. So greater than, lesser than, equal to, not equal to, two examples with strings, and then greater than, equal to, and less than, equal to. And if I click run, I will get the end results of everything, right? So 5 plus 4 is 9, 6 minus 10 is minus 4. I'm not doing the math. Note the difference between division and floor division, right? When I did division, it gave me the exact value that I want. So I did 45 divided by 6, which gives me 7.5. But when I do 45 floor divided by 6, it gives me 7. And it's clearly discarding that decimal part. So note the difference between floor division and division. And then the modulo operator and exponents, quite straightforward. So 5 to the power of 3 is 125. And 5 modulo 3 has a remainder 2, so it gives 2. Then string concatenation, it just joins the two strings together, so I get hello world. Then I have the comparisons, so 4.5 greater than 3, 6 less than 2, blah, blah, blah. And it just like checks if they're correct or wrong. If it's correct, then it says true. If it's wrong, then it says false, all the way down. Is everyone fine? Can I move on? Okay. So that was comparison and arithmetic. Now we'll look at logical operators. So these logical operators also return Boolean values, so true and false, but they allow us to check multiple conditions. So in this case, you have three operators that we're going to look at. You have the AND, OR, and NOT operators. The AND operator checks if both the conditions provided to it are true. So in this case, 5 is greater than 4 and 9 is less than 10. Both of these are true, so the whole thing evaluates to true. In the second one, I have 5 is less than 4 and 9 is greater than 10. Now, obviously, 5 is not less than 4, 9 is not greater than 10. So both of these are false and the whole thing returns false. The thing about AND is both the conditions need to be true, as I mentioned. So if I have 5 less than 4 and 9 less than 10, even though 9 is less than 10, 5 is not less than 4. So if one condition is false, the entire thing comes out false for AND. Then I have OR. So OR is a bit more relaxed. Only one of the conditions that I've given need to be true. So for example, 5 greater than 4 or 9 less than 10. Both of these are true, so the whole thing comes out true. 5 less than 4 or 9 greater than 10. Both of these are false, so the whole thing comes out false. And then in the, again, same example, 5 is less than 4 or 9 is less than 10. Even though 5 is not less than 4, so that's false. 9 is less than 10. So if one thing is true, the whole thing comes out true with OR. And the last one is the easiest one, is NOT. And NOT basically just returns the exact opposite of whatever you passed in. So for example, 5 greater than 4 is true. But then if I put the word NOT just before that, my true gets flipped to a false. And vice versa. If I had a false, my NOT will flip the false to a true. So yeah, you guys can take a couple minutes, go back to your file, and just try out AND, OR, and NOT and see if you guys have got the hang of it. So these logical operators and the comparison operators that I mentioned are often used together for obvious reasons. It's good to check, like, let's say if I want to check if a number is within a certain range, then it's quite straightforward. So we're going to go ahead and just check some things. So yeah, I'm checking if 5 is greater than 4 and 6 is less than 10. Can someone guess, is this going to be true or false? 5 greater than 4 and 6 less than 10. True or false? Yeah, true. Then 5 greater than 4 or 6 less than 2. True or false? True. I mean, okay, it's on the screen now, but true. And the last one, not 5 greater than 4. You don't actually need the brackets, I don't think. Oh, no, you do. Not 5 greater than 4, the brackets are important. So 5 is greater than 4, which is true, but then not will flip true into false and false into true. So that's why I end up with false. Yeah, so these are all the examples that I used to look at all the operators. You guys can take a few minutes. Okay, logical operator is done. Now we look at conditions and conditionals. So we saw just now how we can use logical operators and comparison operators to get like Boolean values, right? True or false. Now we can use this in our program to evaluate certain conditions and how to make decisions and like make decisions about what to do in our program. So a conditional or a conditional statement is essentially just a line in your code or a set of lines in your code that just checks if a given condition is true or not. And then if the condition is true, something happens. But if the condition is not true, something else happens. So in Python, the syntax is very straightforward. I have if, then I put the condition that I want to check. So again, comparison and logical operators are very useful. Then then I put a colon at the end. So if space whatever condition, then I put a colon. Then I hit enter, and you'll end up with, in VS Code, you'll end up with 4 spacing tabs or some number of spaces for tabs. That shows you that all of this is under the if block. It's called a block. And then you can do whatever. Otherwise, you do something else. And not otherwise, else you do something else. I'm just going to type this out. I feel like my words are not great. Let me see if I have an example. Yeah. So what? So you can use any like combination of operators to make your conditions, as long as your conditions are returning a Boolean value. So this is an example, like bit of code that I have. So first I'm checking if the number is negative, then I just want to say, oh, the number is negative. But if the number is not negative, then I want to check a second condition, and I want to see if it's an even number. And if it is an even number, then I tell the user, oh, the number is even. And if that also fails, then obviously it's an odd number. So I tell the user, okay, the number is odd. So here I'm using 2 conditions actually. And the syntax you'll notice is the second condition uses elif. This is the shorthand in Python for else if. I don't know who decided elif is like a good idea, but here we are. So once again, new file or old file, up to you. So first of all, you do need to have the variable number up somewhere. You can just put number equals to whatever you want. I'm going to put it to 123. So if number is less than 0, then I'm going to say the number is negative. Otherwise, if the number modulo 2 is equal to 0, then I print the number is even. Otherwise, I print that the number is odd. So again, I'll go over it one more time. So if the number is less than 0, so I'm using the comparison operator, then it's negative, so I can do whatever. Elif or else if the number modulo 2 is equal to 0, which means that the number is divisible by 2, then I print that the number is even. And if everything fails, I go into the else block and I just print that the number is odd. Do make sure of 2 things, the colon as well as the space. Like the indentation, it's called, just the extra space between the back of the line and where the line actually starts. And okay, great. And if I run this now, I'm going to see that the number is odd because my number is 123. So what happens is that first it checks if the number is less than 0. Is that true or false? That's false, right? Because 123 is not less than 0. So I fail the first condition. I go and check the second condition. The second condition says number modulo 2 equals to 0. 123 divided by 2, the remainder is not 0. The remainder is 1 because it's an odd number. So I fail this condition as well. And then I go to the last one, the else, which is that if every condition fails, come here. And then I print out the number is odd. You can try out different numbers. I can try something like 34. I run this one. It says that the number is even. I can try out negative 34. It'll say that the number is negative. The thing you'll notice is, right, by the time you get to one single block, you won't execute the rest of the blocks in the if-else sort of chain that you have. So in this case, my number is minus 34. If number less than 0, so number is minus 34, which is less than 0, so that comes out to be true. I go into that block, I print number is negative, and then I'm done. I don't do anything else. I skip the rest of it and go to the end of the file, or go to the next part of my program that doesn't have the if-else. Does that make sense? Everything okay? All right. Do I have something before? Okay, no. After this. Okay, so we saw conditions. Wait, you guys okay at the back? You guys okay? Okay, great. So last thing before the break, I'm sorry, I'm going slow, is loops. So a loop is just something or a block of code that you want to repeat a few times in your program, right? And it becomes very obvious later on how it's useful, especially when you come to strings and lists. Um, Python provides two types of loops, a for loop and a while loop. Um, the for loop looks something like this. So the for loop has a counter variable in a certain range. So basically, I can say something like, okay, wait, we look at the exact syntax later, but a for loop starts from a certain value. It has a counter that starts from a certain value and then goes all the way till the ending value and then stops over there. And then for each value, you can do something inside your loop. Your while loop is a bit more simple. So you have while and then a condition. So kind of like your if. And for the while loop, your condition they'll keep checking your condition every single time the loop is sort of run. So if your condition is true, it'll continue the while loop and run that code. Then it'll come back and check if the condition is true again. So as long as the condition keeps evaluating to true, the while loop will keep on going. As soon as the condition evaluates to false, the while loop will end there and you'll continue with the rest of your program. So we'll look at the simpler one first, while loops. This is actually an infinite loop. Don't run this, or you can run this if you want to, but no point. So very simple. So while, then I have a condition. So I'm checking if 3 is greater than 2. And then if that is true, it'll print hello. And it'll go back and check if 3 is greater than 2. And it'll keep doing that until somehow 3 is not greater than 2 anymore. But obviously 3 is always greater than 2 no matter what happens. So this is an infinite loop. It'll never end. We'll now look at a loop that actually ends. So kind of an example problem here. So I have, I'm taking a few numbers from the user and I want to find the sum of those numbers. And I'm just going to keep taking numbers from the user again and again and again until finally the user decides, okay, I want to stop. And to stop, the user has to enter the number 0. And once the user enters the number 0, the program is stopped. So let's try this out. It's not like an exam question. I'm just doing this with you, so don't worry. Once again, in a new file or in your old file, is up to you. So first thing you'll notice, right, you're getting the number from the user. So let's get the first number from the user. So number from the user, I'm going to call the variable number. And then I'm going to ask for input from the user. And I'm going to say, okay, user, give me a number. And then the user will enter a number. Do you guys remember something I mentioned about the input function earlier? About what it sort of does with the user's input? Probably not. I don't think I mentioned it loud enough. But the input function always gets the user input as a string. So even if I enter an actual number, like 5, I get 5 as a string from the input function. Now, how do I typecast a string to a number? Does anyone remember? Well, to an integer in this case, to keep it simple. Does anyone remember? You guys can refer to the slides. Copilot knows the answer. But yeah, it's the int function. So what I'm doing is I'm taking input from the user that comes in as a string. I then pass it into the integer function or the int function, which converts that string to a normal integer that I can actually use in my program. Do note that you actually need to type in like an integer for this to work, because if you pass in something that cannot be converted to an integer to the int function, it will throw an error. We are not going to look at errors too much. We're just going to hope the user is nice and passes in like nice integers as input. So we're going to keep asking for numbers from the user. And we're going to say, while the number is not equal to 0, because as you remember, If the input number is 0, we want to stop the program. So while the user doesn't give the number 0, we can keep asking for input. So while the number is not equal to 0, we can keep taking numbers from the user. That's a nice error message. Message. Okay, so the while loop is going fine, but we do need to keep track of the total value that the user has passed in, right? So we're going to have another variable called total, and this variable will be currently equal to 0. Now, again, just remember, we need to find the sum of all the numbers that the user is giving us, right? This number is inside a variable called number, very convenient. So what do we want to do? Okay, Copilot, stop that. So what do we want to do with total and with number to find that sum eventually? I have my essentially running total, and I want to keep adding the number, the user's number, to the running total, right? So as the number comes in, I keep adding. And then finally, I can use that total and say that this is the total sum of the numbers that you added. So you can use operation assignment. So what I've done is total plus equal to number. It will just add that number to the total, and it'll continue along with the program. And then lastly, I can say this. So the total sum of everything that you entered is this number here. Copilot. Is everyone okay with this program and understands what's going on? Okay, let's. So let's run the. Oh, come on. Let's run the program. Right click. Okay. What do you mean keyboard interrupt? Okay. So we are running the program finally. The program is asking me to enter a number. Let me enter 7. Okay, it's asking for another number and another and another. I'm just going to enter something random, and I'm going to stop here. As soon as I enter the number 0, I'm done. And I get the total sum is 23. And if you actually add up these numbers that I added, so 7 plus 2, 9 plus 3, 12 plus 4, 16 plus 5, 21 plus 2, 23. So that is the correct answer that I'm getting. So anyone wants me to go over this code, like over what I did one more time? Yes, of course. So right at the top, I'm taking input from the user here. That's fine. That's fine, right? That part's fine. So I'm taking input from the user. The input function always gets the input as a string specifically. But can I do addition with a string? Addition, like normal addition? No, I cannot. So to convert that string to an integer, I need to use the int function. Okay? Then I store that number that the user has entered as an integer into my variable called number, right? And that's the first number that the user has input. Okay? So that's the first line covered. In the next line, I am just creating a variable called total. I'm giving it the value 0 at the start. So this total will have the final sum of all my numbers eventually, but right now it'll be 0. Then I have my while loop to keep track of the numbers and the total. So while my number is not equal to 0, because when the user enters 0, I want to stop. So while this number is not equal to 0, I'm going to first of all add this number to the total, and then I'm going to ask the user for another number. And I'm going to keep going until finally this number becomes 0, as in whatever the user enters over here becomes 0. And once it becomes 0, this condition becomes false. I break out of the loop and I end the loop, and then I come to the remaining part of my program, which is just telling the user that this is the total. Is it okay? A bit more clear? Okay. Did you guys try it out on your computers, or did you not get it type? Okay, great. I'll also be sharing all the code and the slides and a bunch of other stuff after the workshop. I'm just kind of, again, this was very last minute. I apologize for that. So basically what I did here with like less spaces, yeah, this is exactly what I did here. I'm not gonna stay too long on this one. So we saw while loops, right? So while loops are useful when you don't know when you want to end. So in this case, the user could enter any number of numbers, right, before they want to finally stop. But sometimes you do know when you want to stop. So that's when for loops come in handy. So you have this basic syntax: for space, then I have a counter variable. I can call that variable anything I want. I is a classic counter variable name, but again, you can use whatever you want. So for I in some range, colon, I'm going to do something just very similar to the while loop. To figure out what range of values you want to go over, there's a function called range that takes, okay, there's a few ways to use this range function. It takes in a starting value, an ending value, and a step value. So you have three options. You pass in range, you pass in just one number into range. So range 5 will start at 0 by default, and then go 0, 1, 2, 3, 4, and then stop before reaching 5. So in this case, it doesn't actually go to 5, even though the number we entered is 5. Second option, as I pass in two numbers, so range 3, 6. So it'll start at the first number, so it'll start at 3, and then it'll go 3, 4, 5, stop just before the second number, which is 6. Okay? And the third way to use it is I pass in three numbers. So in this case, I have 2, 15, and 3. So it's going to start at 2 and end before 15. But the third number is a step value. So instead of going 2, 3, 4, 5, it's going to go 2 plus 3. So 2, then 5, jump to 5, then 5 plus 3, jump to 8, then 8 plus 3, jump to 11, 11 plus 3, jump to 14, and then it's going to stop just before 15. Does it make sense? That's the for loop. That's the range function that allows you to figure out which values you want to go through in your for loop. Why do I have the same slide twice? Anyways, so this is an example. Very simple example. You guys can note this down. So create a new file, or use the same file, is up to you. For I in range 10, print I. So very simple program. First of all, range 10, what values does it go through? It starts at 0, right? Because the starting value by default is 0. Then it goes 0, 1, 2, 3, all the way until just before 10. So it'll stop at 9. And inside my for loop, I'm just printing out the numbers. So I'm just printing out 1, for example. Which is the value of my counter variable. Now, if I run this program, I'll get 0, 1, 2, 3, all the way until 9, and then I stop because it stops before 10. Then I can try a different one. I can go from 5 to 15 and stop just before 15. So this will print out 5, 6, 7, 8, all the way until 14, and then stop at 14. So I try that, and that's okay. This is getting confusing. So I'm going to comment this out just to make it a little less confusing. Yeah, there we go. So we start at 5. That was the starting value. Then 6, 7, 8, 9, all the way until just before 15. So I stop at 14. And then lastly, I'm not doing that. Stop that. Now I'm going through 5, from 5 till 21, but with a step of 3. So I'm going to start at 5, but then each time, instead of going 5, 6, 7, 8, instead of just counting normally, I'm going to add 3 instead of anything else. So I'm going to start at 5, then I'm going to go to 8, then 11, and so on, until just before 21. So I go 5, 8, 11, 14, 17, and 20, and then I stop just before I hit 21. So yeah, these are 3 like examples of very simple for loops that you guys can take a look at. Play around with them a little bit. Okay. So this for loops, so for loops can actually just be written like while loops, but they just look a little bit longer. So I have for I in range 10, I'm just printing out I. So I can, instead of using a for loop, I can do the same thing with a while loop. But I have to do a few extra things, right? My I need to create it myself and say I is equal to 0 at the start. That's outside the while loop. Then my while loop condition is just checking if I is less than 10. Then I'm printing I inside the while loop, and I'm also incrementing the value of I by 1. As in every time I add 1 to I inside the loop. So I starts off as 0. I print out, I check the condition 0 is less than 10, so I continue. I print out I, which is 0. Then I add 1 to I, so I becomes 1. I go back, I check the condition is fine, I print it out, I add 1 again. So I go from I is equal to 2, 3, 4, 5, all the way until 9. And then finally, I add 1 to 9, it becomes 10. And 10 is not less than 10, so I stop the loop there. Okay, a bit more complicated thing, like sample problem. We're going to try. This is a classic problem. It's called the fizzbuzz problem. And you're going to take a number from the user. You can call the number whatever you want. I'm just going to call it n. And then from every number starting from 1 all the way till n, so 1, 2, 3, 4 until n, I'm going to do some checking. So you can use if else over here. If the number is divisible by 3, I want to print fizz. If the number is divisible by 5, I want to print buzz. If it's divisible by 3 and 5, then I want to print fizzbuzz. And if it's not divisible by 3 and not divisible by 5, then I print the number itself. So we can take a look at that. Yeah. So yeah, we'll take a break. You guys can work on the problem. We'll take a break here. You guys can work on the problem and also grab some snacks. I apologize for taking so long. I know it's like almost 8 o'clock. Okay, we'll come back now. If you're still eating, no worries. I'm just going to explain the code anyways for a few minutes. So just to refresh on the problem, you're going to take a number from the user, then let's say the number is called n or whatever you want to call it. So for every number from 1 to n, so 1, 2, 3, all the way until n, you're going to check if it's divisible by 3, you're going to print out fizz. If it's divisible by 5, you're going to print out buzz. If it's divisible by 3 and 5 at the same time, you print out fizzbuzz. And if it's not divisible by either 3 or 5, you print the number itself. You can imagine from like just the ifs and these conditions that are given to you that you're going to be using if else. And another thing is you know exactly when you're going to end. So you're going to start at 1 and you're going to end at n. So this is the code. So this is the code, right? So first I'm taking the input from the user and I'm converting it into an integer as before. Nothing crazy there. Now I'm using a for loop, right? So I'm going from 1 all the way till n. But is there an issue here? I'm using the range function from 1 to n. Could there be a problem here? What does the range function do from 1 to, if I give 1 and n as the two numbers, what does it do? It starts from 1 and then stops where? Yeah, it stops at n minus 1. But I want it to stop at n specifically. So to fix this, I simply add 1 to this to my ending value. So I say n plus 1. And now it'll stop at n. So n plus 1 minus 1, which is n. Then inside my for loop, I can add my conditional statements. So if the value modulo 3 is equal to 0, which means if it's divisible by 3 and divisible by 5, then I'm going to print fizzbuzz. So that's this line over here, these two lines over here, right? Then let's say that condition fails. So elif I modulo 3 equals to 0, which means that if it is divisible by 3 only, then I'm going to print fizz. Let's say that also fails. If it is divisible by 5, I'm going to print buzz. And if that also fails, then everything has failed. So I go down to else and I just print the number itself. And you guys can see that this works out as expected. So I'm going to enter, like, someone give me a number. Jaya, give me a number. 17, okay. So it goes 1, 2, 3 is divisible by 3, obviously, so fizz. 4, 5 is divisible by 5, so buzz. Then 6 is divisible by 3, so fizz. 7, 8, fizz buzz. 11, fizz. 13, 14. 15 is divisible by 3 and 5. So that's why it passes the first condition and it prints out fizz buzz at the same time. And then 16, 17, and I stop. Everyone fine with this example? Everyone okay with this example? Yes, sure. Here you go. So go through the code again. At the top, nothing that we haven't seen before. We're just taking input from the user. We're taking the number and typecasting it. And then assigning that to a variable called n. You can call the variable whatever you want, again, doesn't matter. Just make sure you use the same name everywhere. Then I have my for loop. So for I in range 1 to n plus 1. So this will start at 1, 2, 3, 4, all the way until the ending number minus 1. So n plus 1 minus 1 is just n. So it'll stop at n. And then inside my for loop, I'm constantly doing this if-else check. If I is divisible by 3. You guys do understand that modulo just gives a remainder, right? Which means that if I divide a number by another number, the remainder is 0. That means that number is divisible by the second number. So I'm checking if it's divisible by 3 and 5. If yes, I print fizzbuzz. Else, or else if, I check if it's divisible by just 3. I print fizz. Then I check if it's divisible by just 5. I press buzz, I print buzz, and if everything fails, I type else and I just print I, as in the number itself. So is everything okay? Yeah. So I didn't put it in the slides, but again, I'm sharing the code afterwards anyways. Okay, now we'll finally get into the second half. I know I have like 20 minutes left, but I'll see how much I can finish. We look at functions. So functions are essentially callable blocks of code. Just like any other code or any other program, they will take in some input and they will return some output. That's supposed to be input, that's a typo, sorry. They'll take in some input and they'll return some output. So they're very useful when you need some logic or computation repeatedly throughout a program. And in fact, we've already seen some functions. So the print that you see here is a function. It's a special Python function that just gives output to the user. Then input is another function, so it just takes input from the user. Int is a typecasting function that just converts data from something to an integer. Let me see if you've seen any other functions. I don't think so. Okay, we've only seen print and input, I guess. Yeah, we've only seen print and input. But yeah, all of those are functions. So we've already seen and used some functions, right? And those functions have been declared and given to us by Python directly out of the box. But sometimes that's not enough for us. We might want to make our own functions to do special things that Python doesn't have on its own. So we can create our own functions. To create your own function, you use this keyword called def, which is short for define. You put a space, then the name of the function, you can name it whatever you want. Then you put brackets, and inside the brackets, you're going to have the arguments or the input to your function. And then you're going to put a colon, hit enter, it indents on VS Code, and you continue typing out whatever code that you want to. But okay, so a function can take any number of arguments. It can take 0 arguments. It can take 1, 2, 3, how many ever arguments you want to pass in. Arguments basically just means input values. And to do that, I have def, as in define, name of the function, and then inside the brackets, I have the names of the arguments separated by commas. So I can call the arguments whatever I want as well. So I can have the first one, comma, the second argument, comma, how many ever I want. And then to call the function and to use the function to give it some input and take the output value, we are going to put down the name of the function, put in brackets, and inside the brackets, we're going to give the input to the function that we want to give. Inside the function, you can actually give output through something called the return keyword. So a return value is just what the function is giving back after it's finished with its work. And we'll look at a simple example. Oh, come on. Okay, an example after I explain this part, I guess. Note that the arguments or the input to a function are essentially ordered. So let's say I have a function called f1. I'm taking two arguments called x and y, and I'm just doing something, doesn't matter what. Now, somewhere else in my code, I want to use the f1 function. So I type down f1, I open the brackets, and inside the brackets, I put a comma b. Now, input is always ordered with respect to the arguments. So what that means is, when I run my program and when I call f1 of a and b, a will become x and b will become y. Got it? So this order is always followed. It'll never be that b randomly becomes x one day. So like when you're calling your functions, and you will want to make sure that you're passing in your arguments in the right order. So let's look at a simple function. Let's say you have 2 points on a plane, right? You might remember from like JC maths or whatever. If you have 2 points on a plane, x1 comma y1 and x2 comma y2, you might want to find the distance between the 2 points. Python doesn't have a function for this, but we can write our own. So we're going to go back. We can create a new file or continue working in the same file. And I'm going to call this distance.py. So now, what's going on? So now, I'm going to define a function, right? The first step. So I'm going to use the def keyword, def. I can call the function whatever I want. Let's just call it distance. You can call it get distance or calculate distance or anything you want. You can just call it d or f or whatever. It's going to take in our case, it needs 4 arguments, right? You need x1, y1, x2, and y2, as in the 2 different points that you want to find the distance between. So x1, y1, x2, and y2, stop that. So that's the arguments to my function. And now this is where your math comes in handy. How do you calculate distance? This is just Pythagoras theorem, right? Okay, great, bye. Copilot did it for me, thanks. Okay, this is just math, finding the distance between 2 points where you know the coordinates. You find the vertical distance, horizontal distance, and then you just use the triangle formula to get the value. If you guys remember, the double asterisk is for exponents, which means that I'm essentially doing a squared plus b squared. And then double asterisk 0.5 is basically square root. So I'm using Pythagoras theorem here. So I have my distance function, right? Now, how do I call my function? I just can say distance, and yeah, I can pass in some random points like that. Now, you'll also note inside the distance function, I'm using this keyword called return. So the return keyword basically allows my function to give back some output. And then I can use that output in the rest of my program somewhere else. So I can say that I can assign it to a variable, for example. Let's call my variable d. And then I can print this variable. And if I run the program, let me pull this down a bit. If I run the program, I'll see 5.0. And that happens to be the distance between those 2 points, so 2,3 and 5,7. 5,7. You can try something else as well. I can try, I can pass in negative values as well. This accounts for negatives because we are squaring, right? Yeah, okay, there's a very long decimal value, but yeah, it just calculates the distance between the 2 points that I have given it. So 7.07 something something. Is everyone fine with this? Okay, good. So yeah, this basically what I just did right now. Um, do note that when you want to give output from your function, you always need to give that output using the return keyword. You cannot just leave the keyword out, otherwise your output will not actually, the function will not actually give any output. And we'll just do the calculation and then the calculation gets lost, sort of. Is everyone fine? Can I continue? Okay. I keep doing this. I keep swiping instead of clicking next. Okay. Now that we're done with functions, we're going to do something. We're going to learn about something called iterables. Sounds like a fancy word, but it's actually not, and we'll see in a minute. So there are these things called collections and iterables in many languages, but Python as well. So a collection is a special data type or a data structure which just contains a collection of various items inside of it or various values. Now, iterables are a special type of collection that basically allow a programmer to access values from inside one at a time. There's a formal definition of it for Python, but obviously that's too complicated, so I'm not going into it. But the idea is it's a collection of elements, and I can access elements one at a time instead of having to access the whole thing as is in just like one whole collection. That's the special thing about iterables in Python. Iterables can have two properties. They can be either ordered or unordered, and they can be either mutable or immutable. So in an ordered iterable, the ordering of elements is always fixed unless you change it yourself as a programmer, and it's not randomized. And a mutable iterable basically means that you can modify that iterable in some way. So to modify an iterable means that you can maybe add an element or add an item to the iterable. You can remove an item from the iterable. You can modify the existing values inside of the iterable. If you can do any of these things with your iterable, then it is considered mutable. Otherwise, it's considered immutable. In fact, we saw strings earlier, the things that you put inside the double quotes. Those are considered ordered and immutable iterables. Immutable because you cannot change the value inside of a string. You cannot change any of the characters randomly. You can look at them, but you cannot change them. Ordered because obviously they need to be in the exact order that you put them in at the start. We're going to look at a few more iterables that are very, very useful. The first one is a list. Very similar to the English meaning, is just an ordered list of values. Note that it is ordered. It is also mutable, which means you can add values, change values, remove values. The thing about lists is that you can add in values of any different types into them. So here I have a random list with a number, then another number, and a string, and a Boolean value. I can even nest lists inside of each other. So I can have a list which is made up of lists. I'm going to not have nested lists for now, but yeah. To create a list, you use square brackets. So you open the square brackets, then you put the items one by one. Use commas to separate the items, and then you put the closing square bracket at the end. Then you have tuples. So tuples are like lists, but they're immutable, which means I cannot change the values inside of them. I cannot add more values. I cannot remove values. So once I create a tuple, it's done. It's gonna stay like that for the rest of my program. Same as before, I can just add in whatever type of value I want. So I have two. So I have a bunch of numbers. I have true as a Boolean, and I have a string. Instead of square brackets, you use normal brackets to create a tuple, and then again just comma separated values. So tuples are ordered and immutable. Then I have sets. These are unordered, mutable, and unique. If you guys remember sets from like just math, all the values in it are completely unique, right? So there's no duplicates in the set. Python has this thing where you can only add something called hashable constants to a set. Don't worry about that. Just means that numbers, strings, booleans, and tuples are the only things that you can add in. You cannot add other lists into a set. And then you have a dictionary. So this is a way to put key value pairs. Oh, for a set, you use curly brackets. So you open curly brackets, put the list of things that you want, and then close the curly brackets. Then you have dictionaries that also use curly brackets, but dictionaries are special because you can map a key value pair. So for example, if I want to describe myself, my university, colon, is NUS. My major, colon, is CS. Is graduating just means am I graduating is false. Okay, this is supposed to be this sem, but hopefully I graduate. So is graduating is currently false. Generally, your key is just something that describes the value. So in this case, yeah, my university is the key and NUS is the value. You use the key, then you put a colon, and then you put the value, and then you put a comma for the next pair. Dictionaries are unordered and mutable, which means you can change the values inside them. Am I missing something else? The value can be of any data type, but the key usually is a string or a number. Is convention. You can have keys of other types, but strings are the most common. Strings and numbers are the most common, and I would highly recommend sticking to just string keys or number keys. We're going to look at indexing now. So I mentioned that you guys can actually get a single value at a time from an iterable, right? So let's say I have an iterable called, well, not called, this string is an iterable, and my string is hello. So indexing allows me to access one character at a time. And the way you do it is, you need to know the index or the position of the character you want to access. The first character in any iterable has the index 0 because counting in Python kind of starts from 0 in most languages actually. So the first character starts with 0, has the index 0. The second character has the index 1 and so on. Now, if the length of my iterable is 5, that means the last index is 5 minus 1, 4. So generally, if the length of my list is L, what's the index of the last element? Anyone wants to guess? L minus 1, yeah. Long explanation, no need for you guys. You guys are good enough. Python has negative indexing, which gets very confusing, but is also sometimes convenient. You can start counting from -1. So the index -1 corresponds to the last character or the last thing in the iterable. -2 is the second last value. -3 is the third last value, and so on. So be a little careful with negative indexing for Python. We're going to look at some examples because I think I omitted examples. Great. We're going to create our own examples for iterables, and you guys can just open up a new file or whatever you want. So let's create a list of numbers. So you can Copilot stop. So you can create up a new list, call it whatever you want, and then assign a list to it. So in this case, I just have 1, 2, 3, 4, 5 in my list. What I can do is I can print out the list just to see what it looks like. So I print it out, and I just get exactly what I typed, and I get 1, 2, 3, 4, 5. Very straightforward. I mentioned indexing. So to access the values at a particular index, I take the name of the iterable that I have. Then I put square brackets. Okay, I'm going to remove the menu. I put square brackets. I put square brackets next to the name. And then inside the square brackets, I pass in the index that I want. Note that the index has to be an integer, positive or negative. So in this case, if I want the first value, what index do I use? Yep. So I can print numbers index 0, and it prints out the number 1 over here. I can access a random value. So let's get numbers index 3. And remember, you start with index 0, as in the first character is index 0. So index 3 will be the fourth element or the fourth character. And in that case, this happens to be 4 in my list. I mentioned negative indexing, so I can get the last character, the last element in my list, and that happens to be 5 over here. Okay, is everyone fine with indexing? Wait, I'll just go back to the code. Is everyone fine with indexing? You can repeat the same with any iterable that is ordered, specifically an iterable that is ordered. So strings, tuples, and lists. I can show you another one with strings. So I'm just going to put my name. And then I'm going to print out my name. Then I'm going to print out the first character of my name. I'm going to print out a random character in my name, and then the last character in my name. So if I run this, my name is Prakamya. The first character in my name, as in index 0, is capital P. The index 4 value is small a, that's 0, 1, 2, 3, 4 after the K. And then the last value or the last character in my name is also an A. And you can repeat this for tuples if you want to, but it's the exact same as a list. I'm not going to do that. Should I skip slicing? Should I do slicing, or should I skip it and go to loops? Huh?
You can come back to slicing.
Yeah, okay. I'm skipping slicing because it's a bit complicated. We're going to look at loops. So we saw before, okay, wait, first of all, finding the length or the size of an iterable, right? So sometimes you want to know how big your iterable, how big your list or your string is. So Python has this function called len that just takes in an iterable and returns the length or the size of the iterable. So going back to my example, I can print out the following. I can print out the length of the list numbers from earlier, and I can print out the length of my name, or my first name technically. And if I print that, at the end, I'm going to see that my list of numbers has 5 values in it, which you can confirm very easily because numbers is 1, 2, 3, 4, 5. And the length of my name apparently has 8 characters. I can count that and confirm. So 1, 2, 3, 4, 5, 6, 7, 8. So yeah, my name has 8 characters. So the length function is quite nice to know the length of an iterable. I can do the same with sets or tuples as well. So it's quite useful. Now, this is another thing about iterables in Python, and this is kind of the defining property of an iterable. I showed earlier how you can use for loops to go through a range of values, right? So you start with some number and end with some number. You can use the you can use any iterable as your range, actually. So let's try something. I'm going to create a new file. So my name is Prakamya. I'm going to use my name again. Now let's say I want to print out every single character in my name, right? I'm going to disable Copilot for a second so that it doesn't spoil. If I want to print out every character in my name, I can use a loop. So I just loop from the first character, which is index 0, until the last character, which is the index of length minus 1. So I can say for I in range 0 to length of my name. But in this case, 0 is the default starting value, so I can just say length of my name. And then I can print name index I. So again, going over this, the length of my name is just how many characters are there in my name. And I'm going from 0, 1, 2, 3, all the way until how many ever characters I have in my name minus 1. Because remember, the last character in my name has the index length minus 1. And I'm going through each of those, and I'm then printing out name index I. So the character at index I in my name. Now, if I run this, it's going to print out one character one at a time, right? So Prekamya, and you're done. But the thing is, the special thing about iterables is I don't need to use indexes to go through my my name or like go through any iterable. I can shorthand this to just this. Yeah. So instead of going through the indexes 0, 1, 2, 3, for I in name will just mean that I will now take on each character in that string one by one, or each element in the iterable one by one, and then print out that iterable. So if I run this, save and run. So if I run this, it's coming twice, but still the same thing. The first time is from the earlier for loop, which I showed you, and the second time is from this for loop, which is much simpler, much shorter, and I don't care about the index anymore. Still prints out the same thing, Prekamya. So this is a shorthand way of writing loops. If you want to just go through the characters in, if you want to just go through the characters in any iterable. This works for lists, this works for tuples. I'm running short on time, so I won't go through examples for each of them. But you can try them out yourself. One thing you'll have to note, in this case, I is not an index anymore. It is the exact element in the iterable. So in this case, I is now P, then I is R, then I is A, and so on, instead of going 0, 1, 2, 3. Another thing is membership checking. So there's a keyword, or like I guess it's kind of a logical operator called in, and it's very useful for iterables because it just checks if some value is inside that iterable or not. So this is an example. I have an array with these numbers in it, a list with these numbers in it, and then I'm checking if 10 is inside the array. So it's very straightforward, very simple way to check if there is a value present inside your whatever value, whatever list or string that you have. So it returns true or false like any logical operator. And if it is in the array, then I can print that it's there. If it's not there in the array, then I print that it's not there. That's one example usage of the in keyword. Keep doing this. Should I go through all of this? Wait, how much time do you guys have actually? Like, do you guys need to dip? Because I know it's 8:30. It's up to you guys completely. I'm okay with staying. Okay, I'll just try to finish. Huh?
Yeah,
I'll just try to finish how much ever I can. Strings and lists are probably the most common iterables that we use. So I'll look at a few things, a few methods or string functions that we can use. So string methods are a set of functions that can be applied to strings. You can do a lot of things with different methods, and the way you use them is very simple. Let's say you have the variable of a string. I put dot, and then I put the name of the method that I want to call. And inside brackets, I pass in the arguments that I want to pass in. Does it make sense? So there's a whole bunch of methods. This is not even the full list. There's even more if you go follow that URL if you have the slides. You can convert the whole string to uppercase. You can convert it to lowercase. You can capitalize it. Then there are some checking functions, basically. So you can check if the string is alphabetic, so only alphabets in the string. You can check if the string only has digits. You can check if the string is numeric. You can check if the string is fully uppercase or fully lowercase. You can swap the case in the string, so I can see like everything uppercase becomes lowercase and everything lowercase becomes uppercase. And then there is the index method. So the index method is a bit special. It takes in a character, and then if that character is in the string, it will get the first index of that character. And if it's not in the string, it throws an error completely. So I'll show one example of that. Let me comment out this whole thing. So let's say I'm just going to use my name again. So the way you use it is you put the name of your variable, which has the string, then you put a dot, and then you put the name of the method you want to call. So in this case, dot index, and then you open brackets and pass in all the arguments. So in this case, I want to just check if the character P is there in my name, capital P. And remember, all these kind of checks are case sensitive. So capital P, it prints out 0, which means that the character P is found at index 0 in my name, which obviously it is. It's the first character in my name. Let's say I try character A. Index always finds the index method always finds the first occurrence, so the first time it happens in my name. Now A is repeated 3 times in my name, but the first time it comes is in the third place or the third position, which is index 2. And now if I try to find a character that is not there in my name, so in this case, there's no character L in my name, it actually just throws an error. Yeah, so sometimes a bit inconvenient. You need to make sure that it's in the string or whatever it is before you actually use the function. Again, there's a URL to the full list of methods. You guys can look through that. It's the official Python documentation as well, so it's quite fairly extensive, to be honest. Python has something called f-strings or formatted strings. So it's a way to plug in values into a string to construct a new string. And the format looks like this. So all strings have my quotation marks, but I add in an F at the front of it, which tells Python that this is a formatted string. Then every time I want to plug in a value, I use curly brackets and I put the name of the variable or whatever expression that I want. And those curly braces create slots in the string, and then whenever the string is being constructed, the values get plugged in. So this is useful for situations like this. Let's say I want, yeah, we can use the same example. So let's say I have x is equal to 5, y is equal to 10. And I want to print out like a full sentence saying x plus y is equal to 10. I type F, then I type the quotes, and then I can do this. I thought I disabled Copilot, but okay. And if I run this, the value for x is 5, the value for y is 10. And inside my string, when I'm constructing this formatted string, Python plugs in the value for x in the slot for x, then plugs in the value for y in the slot for y. And then this is a slot which has some addition going on. So it does the calculation or does the addition and plugs in the value of that addition into that slot and then constructs the string. So you end up with this neat looking 5 plus 10 is equal to 15. So formatted strings are very useful when you want to just plug in values of variables into your string and not have to worry about like string concatenation and commas and typecasting and all of that. We look at lists. So lists also have a pretty good set of methods. They use in the same way as string methods. So I have the variable that is my list, then I put a dot and then the name of the method. I mentioned that lists are mutable, which means that I can add values to the list. So if I want to add a value to the end of the list, I can use the append function. So it adds a value to the back of the list. If I want to just empty the entire list, I can use the clear function. If I want to count the number of instances of a value, there's a count function. The index function works the same way. It returns the first index of whatever element that I'm looking for, or it throws an error if the value, it returns -1 if the value is not present actually. Then I have insert. So if I don't want to add it to the end of the list, I want to insert it somewhere in the middle. I pass in the index where I want to insert it, and then the value that I want to insert. So it just inserts that somewhere in the middle. Then I have pop, which removes the element from a specific index. And then I have remove, which removes a given value, only the first occurrence of that value. Then I can reverse the list, so I can just flip the order, and I can sort the list in ascending order or descending order. So I'll show one quick example. Let's say I have my list of numbers again. Let me randomize the ordering. So I have my list of numbers. I can look. Okay, I can append a value. So I'm gonna append the value 42. Then I'm going to insert into the third index. I want to insert the value 420. And then I'm just printing the list as we go along just to see what the value is. And then finally, I want to sort the list because why not? So my list starts off with 5, 2, 99, 10, 2, and -1. I first append the value 42, which just adds it to the back of the list, and you can see that over here. Then I insert 420 into the third index. So index 0, 1, 2, 3 is now 420. And then I sort the numbers by ascending order. So I end up with this in ascending order. So now -1 is the smallest, 420 is the biggest, and it's in ascending order. Let's say if I wanted descending order, then inside the sort, what the hell? Inside the sort, I have to add this little phrase, a little clause, saying reverse is equal to true. And if I sort it now, you see the same things happen as before. I have 42 and 420 being added, but the list is now sorted in descending order. So the biggest numbers at the start and the smallest numbers at the end. Okay, that's lists. What else do we have? I mentioned this before, list and string concatenation. I mentioned this at the start, right? So if you have two strings, you can use the plus operator to just join them up into one. And I can do the same with lists. So I can just join two lists together. So if I have 1, 2, 3, and 4, 5, 6, I concatenate them and it becomes one big list of 1, 2, 3, 4, 5, 6. You can also do this with tuples, but again, this is the exact same behavior. I'm not going to add the example here. This is something that Python has given. It's quite useful sometimes. So you can multiply lists and strings with a scalar. And a scalar is basically a positive integer. So that basically gives you a repetition of whatever the thing was. So in this case, if I have a string, if I have h in quotation marks as a string, I multiply that with the scalar 3, then I get h repeated 3 times. If I have a list 1, 2, 3, I multiply that by 3, then I get 1, 2, 3 repeated 3 times. So 1, 2, 3, 1, 2, 3, 1, 2, 3. And then this is another example. If I have high dash as a string, I multiply that by 4, I get 4 of those. So high dash, high dash, high dash, high dash, with like no spaces or anything in between. And again, this can be done for tuples as well. Do you guys want me to show an example for this? Yeah, we don't have that much time. So I was supposed to go through dictionaries and modules, but yeah, we're well over time. Apologize for that. That's kind of the end of the workshop. I'm going to skip to the end. So thank you for coming to the workshop. Once again, we apologize for the kind of last minute change up. I also apologize for taking so long. Did not think the whole planning through. I apologize for my MacBook slow battery. But yeah, thank you all for coming. If you have any feedback, you can come talk to us. Do we have a feedback form?
I didn't put up one. It's fine.
Okay, never mind. If you have feedback, feedback, questions, anything, do come to me. You can contact me on Telegram, email, Discord, whatever you want. Yeah. See you guys.